This is the homework video for the chapter review for Chapter 4. Got a whole bunch of different types of problems. Chapter 4 has 9 different sections that we covered. So lots of different styles of questions, lots of different things to cover. So jumping in on number 5. We've got an equation with variable on both sides. So we're trying to isolate that variable, get it by itself, combine it down to just one so it's not all over the place. But before we can do anything, we always have to simplify one of the two sides, or both sides if needed. But here the left side of the equal sign is simplified. So the right side is what we need to take care of first. So there's some distributing to do here. We've got a -7, so we're going to distribute it. I'm going to bring everything else down. This is a negative times a positive, so it's -35. It's a negative times a negative, so this is a positive 42. I'm still looking at the left and the right side, and I can do more to simplify the right side. I can combine like terms. So 2f and 42f go together for 44f. And now the right side is completely simplified. So now is when I'm going to start minusing from both sides or adding to both sides, because at this point I don't want f on both sides of my equation. I got to get it down to 1. So you have two options. You can minus the 4f from both sides, which if you're following our rule of always getting rid of the smaller of the two, would be probably what you would choose. But if you do that, this whole side clears out. You got to know to put a 0, and you're actually adding a step because you're going to have to move something back over there and then divide. So in this case, if you want to save yourself a step, you can actually get rid of the bigger of the two. It will create a negative, and we talked about the reason we always get rid of the smaller one is to create positive numbers. But at the same time, we don't need to be scared of negatives. We can handle them. So it's -40f. The -35 comes down as a negative. And we are dividing here, like always, to clear that out. So f equals 2 negatives, cancel, become positives. We have 35 over 40. Now that is a fraction that will not create a nice decimal for us necessarily. We are going to leave it as a fraction, but it does simplify. So depending on what type of calculator you're working with, I'm assuming that most have this style. So on these, the ABC button is your fraction key. So if you do 35 and you hit ABC and 40 and hit equals, it'll simplify it for you. So you have that option. But it's a simple enough one. You should be able to see 35 and 40 both divide by 5. And that's where the 7 over 8 comes from. Now you'll see 7 divided by 8 it's not a terrible decimal, to be honest. So if you left the answer as 0.0875, you haven't rounded it off or anything like that. So that's also perfectly fine. All right, number 6. Here's one where both sides of my equal sign need some simplifying done before I can do anything else. So this will be 14 from 7 times 2 minus 7y. And then 3y, again, multiplying plus 6. So first thing I need to do now that the left and the right side are both fully simplified is just have a y on one side or the other. So I need to get rid of one of these. Neither one will clear out a whole side. So there's not really any worries there. So I would automatically go for the smaller of the two when we don't have a special case like this. So since it's a minus or a -7, I'm going to add 7y. So 10y plus 6. All right, so now I have y just on a single side. I'm going to go ahead and start eliminating. And then divide. Now this creates a nice decimal of 0.8, so that's fine. If you were going to leave it as a fraction, 8 over 10 can be simplified, and it would be 4/5, so that's fine as well. Number 7. Now you can see on number 8, we got a bunch of fractions to deal with, and we've talked about how do you clear out fractions. Which you could do on number 7 as well. You could multiply this entire thing by 3 and it will clear out that fraction. You also could just save it and leave it the way it is and just work with it. But I'm going to suggest you clear it out. I think that's the easiest way to do this. So if there's only one single fraction in the problem, so it'll be different on number 8. But here, we're just going to multiply by whatever denominator we need to go away. What ends up happening is it cancels itself out, and then you're left with whatever's on top. So everything gets multiplied by 3. That's the big mistake that people make, is they just multiply it times the fraction, which in this case is going to leave a 1a. Because 1/3 of 3 is 1, so it's going to be a 1a, so just a. But then you have to make sure everything else gets multiplied here. So this becomes a -3, and this becomes a 9a. Once you've done that step, this is pretty straightforward. You got a on both sides. So we'll get rid of the smaller of the 2. There's no problems here. This becomes an 8a. You're going to divide by that 8 to get rid of it. And you might as well just leave that as a fraction. -3/8. Now, number 8. Let's clear those fractions out. Let's just get rid of them so we don't have to deal with them anymore. Now, you can't multiply by 2 or 5 because it won't work for the other one. So you have to choose a number that both 2 and 5 fit into evenly. Now the easiest way to find that number is to just multiply them together. 5 times 2 is 10. 2 fits evenly into 10 and 5 fits evenly into 10. Everything gets multiplied. So I'm going to get a 10x right here. I'm going to get a 200 right here. Now how do we deal with it when we're multiplying here? So they don't cancel out like we had the 3 and the 3 cancel, because 3 divided by 3 is 1. So 10 divided by 5 is not 1. So it doesn't cancel, but whatever you're left with just gets multiplied times the top. So 10 divided by 5 is 2 times x is 2x. So same thing here, 10 divided by 2 is 5 times the top is 5x. So now I've created a fractionless equation. I do have like terms on this side, so I am going to put them together. 5x and 2x is 7x. And x on both sides, get rid of 1, so minus 7x from both sides. And divide by the 3 to clear it out, not the 200. The 3 is what we're trying to get rid of. And we're just going to go ahead and leave that as our answer. All right, number 9 and 10, we are going to be solving some inequalities. So similar steps as the equations. We'll do these side by side as well. All right, so you would simplify either side if there was anything to simplify. The inequality acts just like an equal sign and splits this into 2 separate sides. So we want one variable, not one on each side. So one of these has to go. With the inequalities, it is important to try and get rid of the smaller of the 2 so you keep things positive. When you keep things positive, you never have to flip. And so many people forget to flip when you divide by a negative, so just don't create negatives and you're okay. So minus 14w, because it's the smaller of the 2. Clears it out. We got 64. This is 3w. And it's pretty straightforward from here now. Like you would always get that w by itself, so I'm going to add 323. So 64 plus 323 is 387. And we're dividing by 3. And we get 129. Now, we didn't divide by a negative, so everything stays facing the same direction. And that's our answer. You'll notice in the book, they wrote the answer like this. says the same thing. These inequalities are read from the variable. It's closed towards w. W is less than or equal to 129. That's what this says too. W is less than or equal to 129. So it's closed towards the variable, whichever way you write it. All right, over here, dividing line, you can simplify both sides. So 20 plus 8t multiplying. And I got to check my handwriting there. That's a 2 plus a t. So that's plus 9t. Okay, both sides are fully simplified. Now let's start eliminating things. I got 8t and 9t, so I'm going to minus 8t. It's the smaller of the two. Keep things positive. And that makes a nice 1t. 9 minus 8. So all I got to do is minus 18, and I am done because I don't have to divide to clear out anything with the t. And so t is greater than 2, which can also be written like this. All right, 13 now. These are compound inequalities. So two inequalities, and the solution has to work in an and or situation, depending on the problem. So for 13, we have this inequality. Our final solution has to work for this one and the other one. And so that's important. And means it works for this and this. Or means either or. All the solutions that work for one or the other. And means all the solutions have to be in both of these, this and this. So first you just want to solve them out. So p is less than 9. Over here you got p on both sides, so get rid of the smaller one. So it's a 1p minus 12. Add 12. There's no flipping because we're not dividing by any negatives. So this is super important. The difference between and or totally changes the answers. So what I suggest is you draw a number line. Here's 1. Here's 9. Imagine what these look like. P is greater than or equal to 1. So that's everything going this direction. P is less than 9. Open circle. Everything going this direction. If this was an or statement, the answer here would be all real numbers, because the solution would be numbers that are greater than 1 or numbers that are less than 9. And that's every number in the world. That's any number. But this says and. So the final solution set to this compound inequality are the numbers that fit this and this. So out here, doesn't work. That only fits this one. Up here, doesn't work. It only fits this one. But every number that's in this part of the graph fits both of these. So from here up to here. Now you can't close this in because that wouldn't be part of this solution. This solution is open. Okay, so you can't close that in. So this is what the graph would look like. So we're going to solve and graph all solutions. Now with these ands, you can always write them as one single inequality. So starting at the 1, it's everything greater than or equal to 1, less than 9. You can write it like that. But you also can write them separately and just put an and between them. And that's fine too. Those say the same thing. All right, 14. So this one's an or. Process is the same, but we have to be careful at our final answers, because they do act differently than an and. So again, the solution to this total compound inequality comes from this or this. So it only has to be in one. It doesn't have to be in both. So let's solve them. Plus 7 Make sure my handwriting is clear. Now, that's not going to be a perfect number, but it is 1.9, so we can deal with that. And here we're going to minus 10. And that's negative 2. So again, this is OR. Now, what does this look like on a graph? Remember, it's OR, so it can be in either one. So here's 0, here's 1.9, here's negative 2. So greater than 1.9, is going to go up like this. This says greater, it's open towards the variable, greater than or equal to, so close, greater than or equal to negative 2. So if this was an AND statement, all of this down here would not be part of it. It would just be from here up. But it's an OR statement, and so it can be in either one. Now, when you see the final answer, you'll notice it's just this. So how come? Because we're going to say it in the simplest form, basically. If you say every number greater than or equal to negative 2, we don't have to say or greater than 1.9, because all of this solution already includes this, right? These numbers that are part of greater than 1.9 are already expressed right here. So since it only has to be in one or the other, not both, every number from here up is part of this or this. It's part of one of them, so it's part of my solution. So when I write my final answer, I don't need all of this. Just look at the graph. What does the graph say? It says S is greater than or equal to negative 2. Okay, so it's kind of like simplifying it. This isn't incorrect, but there's no need to say all of this. If you just say this, it encompasses all of that already. All right, that was 14. 15. So when you see them written like this, where it's kind of combined, you can split it into two pieces, and you need to know that this is an AND statement. Okay, when they're written like this, it's an AND statement. So this is like negative 1 less than 4x plus 7. And the other way, the other piece broken off, looks like this. So it's this, or it's this. You also can solve it together, and some of you know how to do that. So adding 7, well, minusing 7 is the first step on both of them, because you're dealing with the same expression. So you could do it up here, minus 7, minus 7, minus 7. If you know how to work it that way, feel free. I'm going to keep it broken up here, though. Keep it simple for everybody. So I'm going to minus 7 all around. That's going to be negative 8. And then divide by 4. So x is greater than negative 2. Over here, I get 16. So when I divide, I get x is less than 4. Now, this is an AND statement. So we're only looking at the solutions that work for this and this at the same time. So we have negative 2, and we have 4. This one, open circle, greater than negative 2 forever. This one, open circle, less than 4 forever. So since it's an AND statement, we're only looking at the numbers that work for this and this, both of them at the same time. So numbers out here are no good because it's not part of this one, and numbers out here are no good because it's not part of this one. So we're only looking at the numbers in here. Now we're going to have to use open circles. If you close it in, it wouldn't be part of this one. This one doesn't include negative 2. It's just everything greater. So you got to keep it open, and it's going to be everything that's in between. Now for these, this is perfectly acceptable, but you can also write it in one simple form. X is greater than negative 2 and less than 4. 16. Again, this is an AND statement when it's written like this. So this one, I'll show you how to solve it all at once. So you can break it up into two pieces just like we did before. But you can also do it all at once if you want to. You don't have to do it this way. But I'm trying to get d by itself in here. So I'm going to add 40, and it has to happen on all sides. That's the same thing that would happen is if you split this up. If it was just this, you would add 40 to both sides. If it was just this, you would add 40 to both sides. So we're just doing it all at once here. Kind of fancy. Save a little bit of time, I guess. 62. That's negative 15. Now I'm going to divide by 2 everywhere. Didn't divide by a negative, so everything needs to stay facing the same direction. This is negative 7.5, and this is 31. So this is kind of written backwards because normally we have the smaller number down here, but you read it from the letter, from the variable. So this says d is greater than negative 7.5, d is less than or equal to 31. This is an and statement, so it's got to be both. So if I have 0, negative 7.5, and 31, not to scale, but that's fine. So greater than with an open circle, 7.5, negative 7.5, and then less than or equal to, so closed in, 31. Since it's an and statement, we have to find the overlap. Where is this true for both of them, this and this? So that's going to be everything in between these two. But open circles need to stay open circles, okay? Because if you close it, again, you're changing. You're saying that negative 7.5 is now part of the answer, and it wouldn't be part of this one. So since it's and, that doesn't work. Going up, and this one here is closed because this one, d is less than or equal to 31. It's closed. And then this one, greater than negative 7.5, that goes over the 31, also includes it. So 31 is part of both solutions. And you'll see the answer written from smallest to largest. So negative 7.5 here, d in the middle. D is greater than that, and then less than or equal to 31. But you can leave your answer like this. Nothing wrong with that. All right, from 16 now, we're jumping to 20. So number 20 now, we are going to be looking at equations that have multiple variables and solving for one of them, which just means getting it by itself. So we're manipulating things and moving things around so that it's solved for w or for y. So it's still going to be an expression. It's going to be an equivalent equation to what we started with. So k equals s over w. This is one of the most missed questions every time. So we're trying to solve this for w. So here's what everybody wants to do. They want to multiply by s on both sides because they're trying to clear out s to get w by itself, and they see division, so they multiply. But let me show you why that doesn't work. If you try and multiply by s, sure, you're going to get sk over here. But this doesn't cancel. Put it over 1 for a second and multiply straight across. S times s is s squared. Doesn't go away. W times 1 is w. You have not cleared anything out. This doesn't work. Okay, you can't do it that way. What you can do, though, is multiply by w. So in these situations, you can't multiply by the numerator to clear it out. It doesn't work. But you can multiply by the denominator. This says divided by w. It doesn't say divided by s. Divided by w. So I can times by w to clear it. Here's why. Because if I was multiplying straight across with w over 1, I would get sw on top, and I would get w on the bottom. And when something shows up on the top and the bottom, it divides itself into 1 and clears itself out. So now we just have s. So this does clear the w. I just showed y here, leaving me just s. Of course, I've got to multiply on the other side. Some of you would say, well, why do I do that? I'm trying to get w by itself. Well, that's just the first step. I got to get it out from underneath this s if I'm going to get it by itself. So that's the first step. Now, I got to get k out of here. So I'm dividing by k. So w equals s over k. Now I'm done. So on 21, we are solving for y. So that means get y by itself. So we're going to follow the same rules that we always do. We're trying to eliminate the 6x first, and then we'll divide by the 3 to get rid of it. So always get rid of whatever's attached to it last. So a lot of people want to divide by 6 over here just because they're so used to when they see something like this, that's what you do. But think about it as if there's a variable on both sides. How do I get rid of one of my x's? I have minus 6x from both sides if I'm trying to clear it out. It's because if you divided by 6, you would actually leave the x behind. And we're just trying to get y by itself. So we don't need to leave x behind. Let's get rid of all of it together. So we're going to minus 6x from both sides of the equation. Always has to be from both sides. That leaves me 3y. And over here, you can't combine those like terms. Those stay separate. So it's 21 minus 6x. Divide by the 3 now. Now all of this side gets divided by 3. But I'm going to show it as two separate ones. Now you can put the whole thing over 3, but then you're going to end up having to split it up anyway. Now, if neither one of these numbers divide nicely by whatever is on the bottom, you can leave the whole thing over 3. But if you look at 21, it divides by 3. If you look at 6, it divides by 3. So we have to leave them separate so that we can actually simplify it. So 21 divided by 3 is 7, and 6 divided by 3 is 2. Now, some people, when they bring this over, and it's perfectly fine, instead of doing 21 minus 6x, they'll put the x in front. And it'll be negative 6 because it was a minus, and it'll be plus 21 because it's positive. And so this final answer would end up just being the opposite. It would say negative 2x plus 7. And that's the same thing. That's perfectly fine. All right, 22, very similar. Solving it for y, so we have to get y by itself. So first thing we want to do is get rid of this minus 7x, get it off to the other side. So since it's a minus, you're adding 7x. Clears it out. Over here now, you can't combine them, so they stay separate. You can put the x up front, you can put the 25 up front, it doesn't matter. And then you have to divide by 5. Now 7 doesn't divide by 5 perfectly, but 25 does. So I am going to keep them separate. 25 divided by 5 is 5. And thus I'm just going to leave as the fraction 7/5 x. Now if you do divide that, it's 1.4. So if you left it as 5 plus 1.4x, that is perfectly fine. And again, you could reverse the order here. You could put the term with the x first. Nothing wrong with that. Okay, 23. Looking at percent problems here. So how much tax is there on a $32 item if the tax rate is 7.5%? So what's the tax? So we want to find 7.5% of 32. When you say of, it's multiplication. So the percent of something, you're going to multiply the percent times that. But we practice these writing them out as equations. So let's go that direction before jumping to kind of like a shortcut there, knowing that I'm going to multiply there. So we want to know what is 7.5% of 32, because that's the percent of the tax. So the tax is a piece of this. It's a percent of it. But how much? So what is 7.5% of 32? That's what we're looking for. What's the tax? What is this percent in actual dollar amount? So translate this now to an equation. We go word for word. What? That's x. Is equals. Percent has to be transferred to a decimal. We move it 2 to the left. So it's not 0.75. That would be 75%. There's one more spot to go. 0.075 of is times 32. So this is how you solve it. So like I said, when you want to find the percent of something, you're multiplying. There's no division here. X is already by itself. We're not trying to clear anything out. So we're going to go ahead and actually just multiply 0.075 times 32. And you get 2.4. Now we're talking about money here. You're not going to say $2.4. You're going to express that as $2.40. 24. According to the Census Bureau, about 2% of people in the United States are 85 or older. That should kind of make sense, right? Small percentage, 2%, are 85 or older. So if you have a town of 35,000 people, how many people would you expect to be at least 85 years old? So 2% of those people are going to be 85 years old or more. So what's 2% of this? What is 2% of 35,000? What is 2%? 0.02. You got to move it 2 spots to the left of 35,000. So 0.02 times 35,000. 700. So about 700 people. There's 35,000 people total. 2% of that times that is 700. 25 to the nearest percent. So that's telling us we're going to get a nasty decimal, or at least a decimal we have to round. Nearest percent means a whole number percent. Okay, so no decimals in our final answer here. Now you write this out as you read it. 10 is what percent? We're solving for the percent of 23. Now, when you solve for the percent, it gives you the decimal, and you're going to have to turn it back to a percent. It's going to give you this empty spot as a decimal, and you got to put it back to the percent. So first of all, we want to get x by itself. So we're going to divide by 23. And when I do 10 divided by 23, I'm going to write out this whole decimal for you. 0.434778, and that's far enough. There's more than that, but we are rounding this to the nearest percent. But first, before we start rounding anything, we have to make it a percent. We got to move it back 2 spots. So it's 43.478, and there's even more than that. But again, we're rounding to the nearest percent, whole number percent, so no decimals. We're getting rid of all of this. It's either 43 or it could round up to 44%. Rounding is all based on the first number that you drop off. So we're dropping off this number. If it was a 5 or a higher, we would say 44%. But since it's a 4, this will stay 43%. 26. 47 is what percent of 30? So again, solving for the percent, we're going to have to move it 2 to the right once we get that decimal answer. Now, before we even do anything, let's think about this. 47 is what percent of 30? 47 is what part of 30? So 47 is more than 30. It's not a smaller piece. It's bigger than 30. So when it's expressed as a percent of 30, this is going to be more than 100%. So let's not be surprised by that. 47 is what percent, what piece of 30? It's more than 30, more than 100%. So anticipate that as you start doing this problem. 47 divided by 30 is here. Now this one didn't tell us how to round it. So 1.5666, now that's repeated. All right, we're going to move it 2 spots to get it to a percent. So it's 156.666 repeated. That's the percent. That's the final answer now that we've moved the decimal. Now, you could round it. Didn't say to. We do need to know what 0.6 repeated is. That's the fraction 2/3. So instead of rounding it, you could express it as 156 2/3%. Now, that's kind of fancy. Or you could round it 156.7%. Or if you're going to the nearest percent, which it didn't specify, so you could do it any way you want. That 7 would bump this up, and you could say 157%. Because it didn't specify how to give your answer, any of those are fine. 27. 85%. So when I say a percent, I turn it to a decimal. 0.85. Of is times. So 85% of what number? My unknown, what number? Is equals 170. So divide by 0.85. X equals. So 170 divided by 0.85. It's 200. To the nearest whole number. So we're going to round again to the nearest whole number. 6.3%. So again, 2 to the left. That's 0.063. Of its times, what number is 7? Get x by itself. So we're dividing by 0.063. And we get this. Now it says to the nearest whole number. And so we're knocking all this off. There's nothing to round because it's a 1. So it is just 111. Now a lot of people say, well, don't you have to move the decimal? No, this is not the percent. This was the percent. Okay, you didn't solve for a percent, so you don't move the decimal. Very common mistake. Okay, so we're only moving that back if it's a percent that we're solving for. This problem gave us the percent. The number that is our answer doesn't represent anything to do with the percent, so don't start moving it around. On to 29. So for 29, 30, and 31, they're all going back to this absolute value equation. We're going to solve it when n equals 2, so change it to a 2, change it to a 0, change it to a negative. So remember, the absolute value takes whatever total number we get in here, total value, and makes it positive. If it's already positive, it stays positive. But these bars say absolute value of x minus 14. So it's the distance from 0, which is always expressed as positive. So we don't just turn this to a plus. Okay, you get the value on the inside. That becomes a positive. So for 29, we are changing n to 2. So we're going to find the solutions for when n equals 2. So when an absolute value equals a positive number, there's 2 possible answers. This value in here, x minus 14, could have come out to a 2 because the absolute value of 2 is 2. But x minus 14, that value could have produced a negative 2. Because if I got negative 2 in here and took the absolute value, it also would give me positive 2. So I have to go for both of these. Simple math. X equals 16. And x equals 12. So either one of these answers are correct. How about number 30? Still working with the same equation, but when n equals 0. When an absolute value equals 0, there's only one possible answer because there's no negative version of 0. So this in here, x minus 14, had to give me 0. It's the only way I could get a 0. So I only have to solve it one way, plus 14. So x equals 14. And 31, same thing, x minus 14, but when n equals negative 5. This one doesn't have any work to do. You need to think about it. An absolute value can never equal a negative number. Whatever you get in here, no matter what number you plug in, if it's positive, it stays positive. If it's negative, it becomes positive. It can never equal a negative. This is no solution. So again, when absolute value equals a positive number, there's 2 answers. When it equals 0, there's 1 answer. And if it equals a negative, it can't. It's no solution. All right, from here we jump all the way to 45. So we've got these 2 different taxi companies. So we have Taxi Inc. They are charging a $5 fee plus 0.75 per mile. And calling cabs, cheaper up front, $3.50, but they're going to charge you 85 cents per mile. So which one are you going to take if you're only going 10 miles? Basically, which one's cheaper? So you're going to plug into both of these. You're going to plug in 10 for x for both of these and find out which one's cheaper. So you do 0.75 times 10, and that comes out to 7.5, because when you multiply by 10, it just moves the decimal. And when I add those together, This one costs $12.50 if I go 10 miles. This one, when you multiply, so this one, when you multiply by 10, moves it over one spot, and you get 8.5. And when you add those together, it comes out to $12 even. So, of course, which one are you going to choose? The cheaper one. So for letter A, which one are you going to choose for going 10 miles? It's calling caps. So for part B, how about for 15 miles? I'm guessing this one's going to work out the opposite way, just a guess. So 0.75 times 15, 350, plus 0.85 times 15. So let's run the numbers. 0.75 times 15. That's 11.25. So when I add the $5, that's $16.25. This one, 0.85 times 15. That is $12.75 plus 350 comes out to $16.25. So it's kind of like a trick question. Which one are you going to choose? You would say either one. It doesn't matter. And for part C, what is the break-even point? We just found it. It's 15. 15 miles. Break-even means they cost the same. So at 15 miles, neither one is cheaper. Now let's say that wasn't given to us already. How would we figure it out? You would set each one equal to each other because we want to know when are they the same? What is the break-even point? So when does 5 plus 0.75x equal 350 plus 0.85x? And you would solve that. So for the sake of this exercise, I am going to go ahead and solve it and show you that it's going to be 15. So I got x on both sides. I would go ahead and minus 0.75x. So it clears out here, leaving me just 5. And right here, I'm going to get 0.10x minus 350. That's going to be 150 equals 0.10x divided by 0.10. And x equals, when you divide that, 15. All right, so if the question asks when are they the same, when's the break-even point, they're asking when is it equal. And so you set the equations or the expressions equal to each other in an equation and then just solve it. So for 46, comparing two different people, Kim has $15 and is adding to it, saving $9 per week. Alberto has 100 but is spending, so losing, taking out, minusing $8 per week. Letter A. Let x be the number of weeks, so we're going to change w to x. Write a linear inequality, so inequality is a less than or greater than, that can be used to find out when Kim will have more money, so when this is greater, more money than this. So 15 plus 9w, that's Kim. When is that going to be, when is he going to have, or she, more than Alberto? So it looks like that. And then for part B, they want you to solve it. So you have a variable on both sides. Get rid of the smaller one, the -8. So we're going to get a 17w right here. And it was supposed to be an x, but that's okay. Minus 15. And divide by 17. And we get 5. So when w is greater than 5, and they wanted x, so when x is greater than 5. So that's the answer to the inequality. Excuse me. And remember what this talks about is weeks. So once we have more than 5 weeks, Kim will have more money. More than 5 weeks. So 53, another percent question. After a 30% discount, so 30% came off the price. So it's important to think about what percent are you paying when you see that. 30% came off the price. What percent are you paying? A mattress sold for this much. What was the price before the discount? So the price before the discount as a percent is 100%. This number is after a 30% discount. This isn't 30% of it. This is after 30% came off. Original price was 100%. We don't know what dollar amount it was, but it was 100%. They discounted it by 30%. They didn't take $8.96 off the price. They took off 30%, and we don't know how much that is. So if they had 100% original price, discounted at 30%, that means you are paying 70%. $896 doesn't represent the original price, the 100%. It doesn't represent the discount, the 30%. It represents 70%, what you paid. So to answer the question now, what was the price before the discount? So we have to come up with an equation using these numbers here. $8.96 is 70% of the original price. $8.96 is 70% of the original price. Those are the words to help you write the equation. So 896 is 70%, 0.7. You got to move it 2 spots. And you don't need the 0. You can just write 0.7. But 0.70 of is times in the original price. We don't know. That's x. So to solve this, get x by itself, you're going to divide by 0.70. So 896 divided by 0.7 or 0.70 comes out to a nice even $1,280. So 54. These go real quick. Just talking about graphing or writing equations for horizontal and vertical lines. Straight up and down, straight side to side. It's either y equals a number or x equals a number. So we're going to graph 54 and 55 on the same graph. You don't have to do that. So x equals -3. Go to your x-axis. This is your x-axis. This is your y-axis. So you go to your x-axis and you go to -3. And you're going to draw the line that goes right through it. Not this way. That wouldn't make sense because as you go over here, x is no longer -3. On this line, x always equals -3. And y equals 6. You go to 6 on the y-axis, and you draw the line that goes like this. So that, no matter where you go on this line, the x value has changed when I go over here, but the y value hasn't gone up or down. It's still y equals 6. 56. True or false? The graph of all points in the coordinate plane satisfying y equals 23 is a horizontal line. So y equals 23 would be up at 23. Y equals, it'd be side to side. That's horizontal. So that is true. 57. You've got 3 points. If a line goes through it and you notice that all of the x values or all of the y values are the same number, that means it falls on one of these horizontal or vertical lines. Because no matter where I go on this line, I can pick 3 points. The x value is -3. Wherever I go on this line, I can pick 3 different points. The x will change, but the y value is always 6. So what I notice about these 3 points is the x value. Remember, it's always x comma y, alphabetical. The x value is always 5, so the equation is x equals 5. Really pretty simple. And the last one, 58. Looking at the graph, writing the equation. So you see this. Follow that line. Think about what's changing. The y value. I go up, positive y's. I go down, negative y's. So this is not a y equals because the y is changing. But no matter where I go on this line, x is 3. So x equals